Welcome, everyone. I'm excited to have you here today. We're about to dive into an authentic guide to C programming. This presentation will cover the fundamentals, best practices, and tips to help you get started and excel in C. So, let's get started and explore what makes C such a powerful and timeless language. Before we dive into the details, let's take a quick look at what we'll be covering today. First, we'll start with an introduction to the C programming language, understanding its significance and basic purpose. Then, we'll explore the history of C, how it came to be, and why it remains so influential in programming today. Next, we'll examine the general structure of C programs, so you get a sense of how everything is organized. After that, we'll look into the syntax, which is the set of rules that govern how C code is written and understood by the compiler. By the end of this discussion, you'll have a solid foundation to start coding in C confidently. So let's get started with the introduction to C. C is a middle-level language, which means it combines the best of both worlds. It has the simplicity of high-level languages, making it easy to write and understand, yet it also offers the power of low-level languages, giving us control over hardware. Because of this balance, C is ideal for writing both system programs, like operating systems, and application programs that users interact with daily. It's an excellent language for many types of applications, whether they're mathematical, scientific, business-related, or system software. Its versatility makes it a go-to choice in many fields. Another key point is that C includes control constructs, which are essential for writing structured programs. This structure helps us organize code better and makes programs more reliable and easier to maintain. That's why C is considered a structured programming language. C also provides bitwise operators, which allow us to manipulate data at the bit level. This feature is especially useful in system programming, where direct hardware control and efficiency are critical. If some of these points seem a bit complex right now, that's perfectly okay, especially if you're a beginner. You'll understand them better as you continue learning, and feel free to ask questions in the comments section whenever something isn't clear. The history of C is quite fascinating. It was developed by Dennis Ritchie in the 1970s at Bell Labs. This was specifically for programming within the operating system called Unix, which was also a groundbreaking project at the time. C was actually derived from an earlier language called B, which helped shape its syntax and features. Then, in 1989, C was standardized as ANSI C, which helped ensure consistency and portability across different systems. Understanding this history is important because it highlights how C evolved to become one of the most influential programming languages in the world today. Let's take a closer look at the general structure of C programs. First, we have comments, which are essential for making our code understandable. They help us and others know what each part of the program does. Next, we see the preprocessor directives. These are commands that tell the compiler to include libraries or define constants before the actual compilation begins. Moving on, we notice the use of global variables. These are variables declared outside of all functions, making them accessible throughout the entire program. They are useful for sharing data across multiple functions, but we should use them judiciously to avoid confusion. Now, the core of every C program is the main function. This is a special function where the program starts executing. Inside main, we have local variable statements, which are variables declared within the main function itself. These variables are only accessible inside main, helping us manage data specific to that part of the program. You'll also see other functions like func1 and func2. These are user-defined functions that perform specific tasks. Each function contains its own local variables and statements, making our program modular and easier to manage. Finally, note that the main function ends with a return 0 statement, which signals successful execution to the operating system. Overall, understanding this structure helps us organize our code logically and efficiently, fitting into the broader theme of writing clear, maintainable C programs. So, what is syntax? Well, a programming language's syntax is basically a set of rules that tell us how to formulate statements correctly. It's like the grammar rules we follow when writing sentences in English. These rules answer the important question of, how do I write the code? Think of it as the grammatical structure for programming. Just like in English, where incorrect grammar can make your sentence confusing or unacceptable, in programming, incorrect syntax can cause errors or make your code unrecognizable to the compiler. The syntax ensures that your code is written in a way that the compiler can understand and accept. So, mastering the syntax is crucial because it helps you write correct, effective code that works as intended. It's a fundamental part of programming that connects directly to writing clean, functional programs within the overall theme of understanding how programming languages work. Thank you so much for being with me throughout this journey. If you found this series helpful, please subscribe for more detailed videos on C programming. I want to leave you with an important warning. Do not jump straight into writing and memorizing code. Instead, take it step by step. This approach ensures you truly understand each concept, which will make you a better programmer in the long run. Remember, learning C is a process, and patience is key. Keep practicing, stay consistent, and you'll see progress. Thanks again for your time and happy coding.